My pleasure. Thank you.
Dr. George, I managed the National Council for Air and Stream Improvement Forest Watershed Research Program for 35 years out of Corvallis, but really working nationwide. I became familiar with him initially through working with him on the Watershed Management Council some years back. His work focused on the effectiveness of silvicultural best management practices and the attainability of water quality standards. George is retired, but he's still working like the rest of us. So George, there you go. It's up to you now.
Okay. Can you hear me, and do I have control?
You have control.
Okay. Well, Liz's presentation really highlighted some of the key themes that I'm going to hope to cover over the next 30 minutes. Things like the use of controls and benchmarks to assess response, quantifying effectiveness, timing of response, legacy contributions, things like practicability and the costs of alternative active management practices. And it's not going up or down. Oh, thank you. Okay. I think that we recognize that we've really made incredible strides in addressing water quality impacts. If we work and look at the progress that's been made since the 1972 Water Pollution Control Act amendments, we can see just dramatic improvements in water quality impacts from forestry activities compared to some of the legacy impacts that we saw pre-1972 amendments. Things like the splash dams that we heard about earlier, log drives, even active cleaning in streams with tractors to remove wood from those stream systems. And so there was this development of best management practices or forest practice rules, which allowed us to address many of these concerns.
George, are you there?
I am. I'm trying to get it to move, and it's not moving.
Okay, let me move it for you. You just cue me, and I'll move the slides. Okay.
Okay. Next slide. So one of I think the great stories that about the effectiveness of our current best management practices is a comparison of studies that was done by John Hewlett and then some others in the Piedmont region of the South. And you'll see this is an example of the first-year sediment response to different paired watershed studies. And you see this tremendous first-year sediment loss from the Hewlett study. Well, this was a study done by John Hewlett at the University of Georgia on the Grant Forest, where they were looking at a logger's choice operation. And after Hewlett had done this study, he concluded that if they'd just done three things, they could have reduced the impacts by about 90%. Those were building better roads and maintaining those roads, not using mechanical planters that disturbed the gullies that had been formed during the cotton era, and adequate riparian management areas to provide sufficient protection of the channel. And when subsequent studies were done in the South, in the same region, they saw about that 80 to 90% reduction in sediment that Hewlett predicted. So we see that we can really have a major impact on the water quality impacts of our management activities through the use of buffers and riparian management areas. Next slide. So why do we need to monitor active management? We need to determine whether we're achieving our management goals. Do we understand the mechanism that underlies how we're impacting water quality or habitat, so that we can extend our findings to other sites? Are we avoiding unintended consequences? And I think this is a real important one for thinking about active management. And then how do we maximize our return on our active management investment? to me, active management is kind of an interesting one because we're looking at different types um, of monitoring and assessment methods. We're really taking advantage of methods from timber inventories, from reforestation surveys, from BMP effectiveness studies, because we're at this interface between the terrestrial and the aquatic. And so as we try to assess what our impacts are, what our benefits and our costs of our active management, we have to look at both the terrestrial and the aquatic system. Next slide. And I would caution that you need to think about this tale of two signs. Here are two signs looking at the two different sites that stream enhancement projects that occurred. You see one, proudly discussing a fish passage project, and then the one on the right is a landowner who was upset with a riparian stream enhancement project and considers it a waste of dollars. So what type of information do you have to address the concerns that might be raised about your active management proposal? I think one of the unique things about thinking about active management is what different levels of management will create as far as problems. Maintaining a buffer without active management, will that result in shrub community development with low large wood recruitment potential? Will active management increase the potential for invasive species? And so we have to look at what are the problems that may be associated with alternative management strategies. Next slide. So we can set up, I think, what are key questions and then look at some potential hypotheses, and that can help us to identify what are going to be the best monitoring strategies and what types of parameters do we need to use to assess as far as our benchmarking against our impacts. So looking at maybe goals that we might have under an active management schedule, we might want to accelerate mature or old growth forest characteristics. We might want to change from a hardwood dominated system to a conifer system. We might want to improve fish habitat by increasing light and primary productivity in the stream, or we might want to create snags or other features that are favorable for wildlife habitat. But then there could be potential unintended consequences related to our different management strategies. So for example, buffers left in place might ultimately result in shaded unproductive reaches for fish. If you actively manage these to increase the size of the individual trees in these riparian areas, by thinning, you might increase blowdown. If you try to convert to conifers, you may have animal browse or other problems with reforestation. Again, invasive plants or changes to other undesirable species. And so these are, I think, we need to look at both what are our objectives, but also what are the potential negative effects of any active management activity and how can we monitor for those. Next slide. Again, this will allow us, by thinking about this will allow us to develop some potential hypothesis statements like thinning the riparian forest will accelerate the development of old growth forest characteristics. Thinning will not increase short-term blowdown of riparian trees. And these are, again, testable hypotheses that we could set up a study to monitor and understand whether these are or are not occurring. Next slide. Let me give you an example of maybe looking at monitoring for a particular active management activity in a riparian area. A couple of years ago, I went on a tour of some Bureau of Land Management riparian active management sites, and they were trying to restore conifers to sites that they believed were depleted of conifers and were had excessive hardwoods. And so we talked about the difficulties of getting these conifers reestablished, and we talked about what were the prescriptions that they were using in these riparian areas in order to achieve successful regeneration of conifers in these sites. And what were they doing? Well, they needed to get full sun and minimize the understory competition. They needed the appropriate species in these sites. Here we see, I think, western red cedar. They needed large, healthy seedlings, and they needed to control animal damage. These sound like the same types of prescriptions that you would see at an upland site, except that maybe these problems are exacerbated in this riparian area. Next slide. So if we look at this slide, this is some data from Mike Newton where they were looking at establishing conifers in a riparian area, and it's a nicely designed where you have nearly 1,000 seedlings here, planted here, looking at the cause, where possible, to identify the cause of mortality for these trees or success of the trees. Looking at on the edges, you see overstory was present. In the middle, you had an opening, and portions of it was weeded. Other portions were unweeded. But you can see, particularly at the edges, that there's quite a bit of mortality that's not related to animal damage, which appears to be a result of shading of these species. And then you see quite a bit of mortality related to both mountain beaver and beaver in these riparian areas. This type of information allows us to identify what are going to be the issues related to some sort of an active management program to try to get conifers back into a system. Next slide. This again is sort of a quantification of this, looking at the cubic centimeters in the fourth year stem volume, and looking at how the overstory and shrub cover affect the success, the volume, in this case, of Douglas fir that were planted in this riparian area. And you see this very strong response to light. So again, the Douglas fir just is not succeeding where it's either covered by the overstory or the shrub community, but where it's open, you see a very, very successful response. Again, this is trying to quantify this so that the manager in the future can make a decision about how he's going to be able to achieve his management objective. Next slide. Several years ago, that's 1999, we worked on a project looking at methods that could be used in riparian areas to assess what the conditions are, the features and the functions of those for both wildlife and aquatic conditions. Next slide. And you'll see here that the sampling design, this is a pilot project. We went to 20 different sites in Montana, Oregon, and Washington to try to develop these methods that could be used to assess the condition of a riparian area, looking at things like the channel characteristics, the overstory and understory and cover conditions, large wood, all sorts of different things. But we were forced, because of the variety of different parameters that needed to be assessed, to use different approaches and methods. So in some cases, we were using transects to assess the understory conditions. In other cases, we had plots in the measurement points in the channel in order to measure things like substrate condition or stream confinement, and then we actually had inventories of all the trees in order because of their importance, in order to quantify just what were the characteristics of this system. Next slide. So, for example, looking at the stream and riparian measurements, we had measurements like the width and gradient, substrate, whether it was confined or unconfined, and what the channel type was. For the channel, we looked at things like the shade, both canopy and topographic shading, large woody debris in the channel, and bank vegetation cover. For vegetation, we looked at the species, whether there were seedlings, and the species of the overstory canopy. For riparian physical measurements, things like soil disturbance, the presence of slash, what was the slope, riparian habitat, things like down wood and snags. And then for the riparian trees, there was 100% inventory of trees greater than 8 inches in dBH. And we also looked at where they were positioned in the stream as a way of helping us identify whether they could contribute to large wood in the future or not. So these, and because of the characteristics of these very different measurements, you're forced to use different schemes like plots or points or transects. Next slide. One of the challenges is that when we try to make certain measurements, we're faced with many different options. So for example, trying to characterize whether a stream might respond to some active management to increase light, both positively by increasing primary production or negatively by increasing temperatures, we can look at different types of measurements, things like the canopy cover, which is the percent of the sky covered by the vegetation, or the shade, which is more of a measure of obscuring of the light to the stream surface. Next slide. So just to quickly go through some of the options that you might use. You might use a clinometer to measure the view to sky. Next. You might use an ocular estimate of canopy closure. Next. You could use things like the moose horn densiometer, which allows you to look up and above the stream and evaluate cover. Next. Spherical densiometers, which are commonly used, and these can be used either to look at cover or look preferentially towards the south to identify critical shading from the key sites. Next slide. Angular canopy densiometer, where again trying to look at critical time during the midsummer and late summer to identify which vegetation is contributing to shading during those critical times. Next. Hemispherical photography, which certainly can be used to manipulate it to look at critical shade components. Next. Or even direct radiation measurements with a pyroheliometer. Next. But I think the key coming out of one of our keys coming out of our study was that these are measurements that are used, but they commonly used, but they don't often. In some cases, they will not correlate well. Here we have a measure at these 20 pilot sites, looking at angular canopy density versus shade measurements and seeing a very, very poor correlation between those measurements. Now, if we look at the averages for these sites, it was a better response, but for these individual points within these 20 stream sites, there was a poor correlation between the angular canopy density measurements and the shade measurements. Next. I think we can also learn a lot from the BMP effectiveness studies that have gone on over the years. In BMP effectiveness studies, we're looking at things like what are the potential best management practices or forest practice rules that could be applied? Are they effective? And trying to quantify the differences with and without BMPs. How do we select between these infinite set of performance measures and scales that we could use to assess these? Next slide. Again, several years ago, the National Council put together what we call the Control and Mitigation Handbook, and that's since been updated by our Canadian component of the National Council. And one of I think the neat things about that handbook was it was an attempt to try to summarize what types of practices you might use to address a water quality concern that you might have on your ownership. And with each of the measures that were included in the Control and Mitigation Handbook, we included things like a general description of what that management practices might be, a synthesis of the effectiveness to try to really quantify what you might expect if you employed that that practice, some cost estimates, because the land manager is going to make decisions between different options. What are the limiting factors? So in some cases, these practices might not work because of certain conditions, and there may also be complementary measures that you could use to enhance their performance, and finally, literature references to look at that. But I think this question about cost and practicability are ones that are important when we do adaptive management assessments. Next slide. Next slide. So maybe an example of just how important it is to have these types of options and to look at different active management options, say, is here's an example of skid trail erosion that was done. This study was done by Dale McGreer in Idaho, and what they were looking at was skid trails. They had sediment traps below skid trails, and they were under different conditions. And so on the far left, you have a site that has a litter layer and ash cap still intact because the skidding has not been numerous enough or damaging enough to remove those. The next site you see where the ash cap is still there, so it has a high infiltration rate, but the litter layer has been removed. And then finally you see where both the ash cap and the litter layer have been scoured off due to yarding off on these skid trails. But then you see something on the right, and you see this subsoil and S. Well, that's where you had the same conditions as you have in the higher bar sites, where you have exposed both the subsoil by removing both the ash and the ash cap and the litter layer, but you've come back and added slash to this site. Well, from a practical standpoint, this makes a tremendous difference, because you can then have designated skid trails where you can focus your operations and reduce the extent of your disturbance, and then come back, put on that slash, and achieve nearly the same levels as you would have achieved had you retained the ash and litter layer. So I think this is an example of how, if we monitor for active management and we can find tools that can really help us achieve our objectives. Next slide. Liz talked about North and South Fork and how important it was to have controls to try to understand where you had variability related to storm events and other factors. You know, in our traditional paired watershed approaches, we have a period of time where during pre-treatment where we develop a relationship between a control and a treatment. Then we develop a statistical relationship between those, develop confidence limits, and look at what the treatment effect is, and then assess whether or not we're within the boundaries of that confidence limits or not. Next slide. Here's just an example of some data where we have pre-treatment for salmonid volume, or grams of salmonids for the North Fork and South Fork of Hinkle Creek. And this is data from Doug Bateman from Oregon State University. And one of the neat things during this monitoring is that you see this relatively consistent pattern of response prior to any management and the pre-treatment level in the pre-treatment period. Then there's two logging arrows that occurred. One is in the headwaters, and we see a relatively small response to that, and then a larger response in 2010 and later after harvesting that occurred near the riparian areas. And the South Fork in this case is the sites that receive the harvesting activities. And so by having a control, we can try to understand, is there some process that's going on here that's resulting in a response. Without that control, we might not have been able to identify what was, whether or not there was or was not a response. Next slide. One of the other approaches, of course, is a similar approach is what we call a Bakke design, a before-after control impact, where you have again a pre-treatment period. Then you have you develop a control and in a site that is impacted. In the Ripstream study in Oregon, we have what's a replicated Bakke design, where you have control reach between stations 1 and stations 2, and then a treatment reach between stations 2 and stations 3, and the control reach can be used to help to identify whether there are weather conditions over a particular year that will be influencing what we see in the treatment reach between stations 2 and stations 3. And then there's actually a station 4 in this study, which allows us to identify what the recovery is downstream. But this is, again, with replication, so there are 33 sites on state and private lands that have this design, which allows us to look at response over time. Next slide. And you may have heard last week, at the last session by Ken Cummins, presentation talking about a study in Northern California, which many of you may be familiar with, that Peggy Wilsbach did, testing the effects of riparian forest removal and salmon carcass additions, where she had 6 streams that she separated segments and looked at the trout response to alternative treatments, including controls where they were left intact, riparian where riparian alder were removed, and also where carcasses were added to the streams. Next slide. Next slide. And so, again, kind of a real interesting response here with this replicated block, incomplete replicated block design, where the fish productivity seemed to respond most to the increase in light rather than to the carcass additions. Next slide. I think we're really, as we look at BMP effectiveness, oftentimes the focus is on what's the effect on fish and fish habitat. And so a lot of studies are going to the use of these pit tags, where I always call them as barcodes for fish, where these small tags are put into the fish, and you can then either track them moving between segments with these gate readers, or identify them with mobile tractors as you can walk through these streams. And you know what that fish is, what its conditions were previously, and then you can determine how it's responding to any management activities. Next slide. So here's just a little data from, again, from Doug Bateman from the study in the Alsea watersheds, where Flint Creek is a control watershed and Needle Branch is a treated watershed. You see harvesting occurring in 2009. And what this is showing is where is the biomass, where is the point of 50% of the biomass captured in these streams. And so that you can see that prior to the harvesting activity, that the biomass was relatively consistent between the two sites, but then after the logging you get this separation occurring. And for Needle Branch, the biomass seems to be moving higher upstream. Well, how can we interpret this? Well, one of the things that's happened here is that the harvest occurred only in the upper portion, the upper half of Needle Branch, and so we're seeing a response mostly in the area that was harvested. So again, this allows us to make an interpretation about any active management that might occur and how that's affecting the fish response. Next slide. I'm going to just talk a little bit about performance benchmarks. What do we look at to try to evaluate effectiveness of an active management activity? We've got paired sites. We compare them with sites that do not have active management, so that's one way. We can use old growth sites or mature reaches. That might be another way, or least impaired water bodies. Next slide. One performance might be water quality standards. So, for example, in the original Alsea watershed study, Needle Branch, you see the FC at the top left. That's Flynn Creek, which was the control watershed, and it always maintained dissolved oxygen at around 11 milligrams per liter. In the treated watershed, which had lots of slash introduced, and it was increased temperature, we see dissolved oxygen levels dropping below the water quality standards, and the two red lines represent the range of dissolved oxygen criteria that the state of Oregon has, depending on different conditions and what the dissolved oxygen levels are and the temperature is for that stream. Next slide. However, like many other benchmarks, you have to be cautious about using a water quality standard. This is some recent data from Needle Branch looking at stage and dissolved oxygen level, and we're seeing at very low discharges that we have very low dissolved oxygen levels, well below those that are part of the water quality criteria, state water quality criteria. And what we have is a discontinuously perennial stream that goes subsurface for many of its reaches. So just during those very low flow periods, we have low dissolved oxygen concentration. Next slide. Aha. So one other, of course, is to look at natural disturbance events and to see whether those might cause impacts that even exceed those that we would see for our active management activities. Next slide. And again, we just seem to there's a potential for. We're getting a lot of chatter in the back. And there is when we talk about biological response. When we talk about biological response, we have many different options that you could look at. You could look at fish, you could look at macroinvertebrates, you could look at amphibians. If you choose fish, you could use coho, you could use sculpin, or cutthroat trout. If you look at coho, you might look at net productivity, condition, fecundity. You might look at different periods of time, different ages of the fish. And so there's a lot of choices that we need to make if we're going to make our best effective monitoring of our biological response. Next slide. I think one thing that's useful is to look at multiple indicators. So we had a study one time where we were looking at bull trout and trying to understand what the effect of temperature was on bull trout. And this slide here looks at growth rates for bull trout, and it also compares feeding levels. And so we had between 100% and 11% of satiation feeding, and we had different temperatures. And you see the temperature response was relatively mild, but the food response was pretty dramatic. Next slide. So that, some people might not be convinced by that, but we had other multiple measurements in this study, and including heat shock protein formation. This is not a heat shock protein formation for bull trout, but it's an example for Chinook salmon, where you can see that the Chinook salmon weight change seems to be responding at the same time that they're developing these heat shock proteins. So there's a biochemical measure that helps us to interpret that, yes, this is a real response. This is something that we can believe is an action resulting from a temperature stress. Next slide. Next slide. Okay. So we've talked a lot about measurement opportunities. Alternative scales, I think, is another one to think about. We tend to monitor at the reach scale, but sometimes we need to interpret at the landscape scale. And we need to think about both the timing and both a spatial and a temporal scales. So, for example, if we're looking at wind throw, we may need to look at a testing storm to determine whether wind throw is affected by our management activities. We need to look at the landscape sometimes to interpret how our active activities are affecting our habitat. Next slide. I think one of the most influential studies I know of related to habitat and fish was one by Conley and Hall, which looked at the biomass of 1+ and older cutthroat trout and found that sites that had low conifer levels, so they had higher hardwood levels, but had abundant large wood, were the most productive for the trout. Now, if you think about a site, the only way you get large wood is by having conifers, and yet those are also conditions that are leading to lower productivity levels. And so there has to be some sort of evolution or cycling over time of riparian conditions in order to get optimum habitat for the trout. Next slide. I mentioned practicability under the best management practices. We talk about technological, institutional, and economic practicability. You know, is the active management practice technologically feasible? Do you have the technology to do it? Is it institutionally feasible? Do we have helicopters in the area that can do it, and is it cost effective, or are there other approaches that might be used? But I think we need to quantify these as we make judgments about active management activities. Next slide. I'm going to close just by saying that there are some monitoring opportunities that you can use, or think about anyway. I'm going to use the example of Schooner Creek, where I took a tour a couple weeks ago on the Oregon coast. It's been an area that's received active stream enhancement efforts. But some of the conditions that would make this really a great opportunity for monitoring active riparian management activities include has paired forks, a north and a south fork, both with fish populations. There's ongoing monitoring by the Oregon Department of Fish and Wildlife in both of these forks, and there are both federal and private lands in the Schooner Creek watershed. Next slide. So, you know, the question is why it'd be an advantage to have some sort of a mixed ownership where you have private and public lands. In the case of the ALSE watershed study, I think we found that very valuable because on the federal lands have reference watersheds that haven't had management activities since the 1800s, which we can use as a control to assess our water quality impacts. But then we have some other management opportunities on the private lands that we would not have on the federal lands. So, for example, you can see here a harvest occurring along the riparian areas in the headwaters of Needle Branch as part of the ALSE watershed study. Next slide. And so we were able to get the loggers, and the company agreed to this to allow as a test of whether or not the riparian transpiration was affecting diurnal fluctuations in stream flow. We were able to get the loggers to do a harvest only along the riparian area prior to the full harvest. And this is a reach that is a non-fish bearing reach, and under the forest practice rules, on private lands, you can harvest the trees to the stream channel here. And so we were able to do this type of test, which might not have been able to do in a single ownership study. Next slide. So in conclusion, I think the question about what is the desired future condition for a riparian area and what are the key functions and benchmarks are going to be critical to designing any study. Fish is certainly oftentimes the focus, but it could be wildlife habitat, or you may use some surrogate measure like mature forest condition as your benchmark. What will the performance be measured against? You can be looking at lack of management activity or some historic practices and how we're addressing those legacy conditions. It's useful to have control watersheds to quantify what the impacts are. Sometimes we can use water quality standards to evaluate whether, for example, temperature or sediment may be increased beyond acceptable levels. Key to doing some sort of an assessment is to develop some sort of a control or pair to evaluate with and without those active management. And I like to look at where are there some special monitoring opportunities like the presence of mixed ownerships and ongoing monitoring of fish populations. So with that, Richard, I'm done with my presentation and happy to answer questions.